Assalamualaikum, nama saya Muhammad Alif AIMAN. Hari ini saya nak beritahu cara-cara untuk cari nilai mean, nilai standard deviation, nilai minimum, nilai maksimum menggunakan Excel. Okey, untuk cari nilai mean bagi X, kita guna average. Lepas tu kita highlight row 1 sampai ke row 100 dan kita akan dapat nilai mean X. Untuk cari nilai mean Y, kita highlight dari row 1 juga kepada row 100, tekan enter, kita akan dapat mean Y. Untuk cari standard deviation, kita buat benda sama, kita highlight dari row 1 kepada row 100, tekan enter dan dia akan keluar nilai dekat sini. Okay, selepas itu untuk cari nilai standard deviation bagi Y, kita highlight row 1 sampai ke row 100, tekan enter, kita akan dapat 1 point, ni nilai dia. Itu untuk cari nilai maksimum. Untuk Y sama, kita highlight row 1 sampai ke row 100, tekan enter, dia akan keluar nilai ni. Untuk nilai Y, kita highlight dekat D ni, row 1 sampai ke row 100, tekan enter, dia akan keluar nilai ni. Untuk cari minimum pun sama, kita guna ni min, lepas tu kita highlight dari row 1 pada row 100 kat sini untuk nilai X, lepas tu dia akan keluar ni. Untuk nilai Y, kita highlight dekat D ni, row 1 sampai ke row 100, lepas tekan enter, dia akan keluar ni. Okey, terima kasih. Okey, saya nak yang ini part 2, saya nak explain tentang nak buat scatter diagram. Okay, untuk scatter diagram, mula kita tekan insert, kita tekan chart, kita ambil yang ni, scatter ni, tekan, dia akan keluar graf macam ni. Okey, okey, lepas tu kita pergi dekat design. So kita nak element apa, macam ada ni. Okay, kalau kita nak yang macam dalam rajah ni, kita ambil yang linear dan akan keluar satu garis panjang. Okay, thank you.
Hi and Assalamualaikum, my name is NORASHIKIN binti NASARUDDIN. My matrix number is DE 190039. I will explain how to find the question C. Assuming a linear relationship, use the least square method to find the simple linear regression model. This is the answer that I found in Excel, and this is the manual calculation. And I will show how to find one by one in Excel. First, we need to find X times Y. Just type in formula bar, while bracket, click X, the value of X, and times the value of Y. Close bracket, enter, and we got the answer. Drag this cursor, drag, and we got all the answer of X times Y. To find X squared, equal power the value of X and the power of 2, and we got the answer. Drag the cursor until the end of our data, and we got the answer, all the answer of X squared. For Y squared, power the value of Y and the power of 2, and we got the answer. Drag the cursor, and we got all the answer of Y squared. To find n is the sample of our data is found and the value data. And we know our sample of data is 100. To find the sum of multiple terms of x is just type the function sum and click the value, all the value of x, and we got the answer. And to find this, same as to find the sum of all x, sum the value of y, all the value of y, drag the cursor to all the value of y, and we got the answer. Same as this, all the value of x times y, drag the cursor, drag the x squared, all the value of x squared, and last sum of the value of y squared, drag all the value of y squared, and to find the xy, this is the formula. We click the sum all of multiple terms of xy, so this just click plus minus 1 over n times with the sum all of x and times with sum all of y, and we got the answer 14.2480. And to find sxx, this is the formula. Just click in the formula bar, click this, minus with 1 over n times with sum all of x to power of 2 and we got the answer 999.8086. And to find beta 1 x, this is formula xy over xxx. So type in formula bar x, just click with the value of sxy over this sxx and insert, and we got the answer. For beta naught, this is the formula. Click the value of sum all of y is over 100 minus with beta 1, select the value of beta 1, times with sum all of x over 100, and we got the answer negative 0.08180, and we know this answer same as the manual calculation. To prove it, we got the report and we got same answer. Beta naught negative 0.0818, beta 1 0.1428, sxy 14.2480, sxx 99.8085, and y-intercept we got 0.1428x minus 0.0818, and we know all the answer is same as the simulation in Excel. I will continue with question D. Check the significant alpha 0.05 of the simple linear regression model in C, and we got the answer. To find this, go to Excel, And this is our data, 100 data. Go to data and select data analysis and select regression. Click OK. For input Y range, select all the input of Y. And for input X range, select all the input of X. Click the confidence level and click OK. And we got the summary output. And we got the summary output. The coefficient of intercept and X variable. This is the value of the coefficient of intercept and X variable. Standard error of intercept and X variable. Slope. T-statistic. P-value. Lower and upper confidence level 95%. And we also get the value of F and significant F. And we got also the regression statistic.
Assalamualaikum. Today I will be presenting about the part E, which is the meaning of the intercept and slope in the problem, in this problem. And then please comment any impossible event. Okay, for the first, if the slope, if the time elapse increased by 1 second, the data predict the average of computational elapsed time approximately 0.0128. Okay, for the second, which is intercept. If the intercept time elapsed is 0 second, the data predict the average of computational elapsed time approximately negative 0.018. Okay. For the last is comment, which is I noticed that it's not necessary to fully understand the units in which the variables are measured in order to correctly interpret this coefficient. While it is good to understand data truly, is also important to understand the structure of the line models. So, based on the slope and the interception, if the time elapsed increase, the average of computational elapsed time also increase. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and hi doctor. My name is Anissa SYAFIQAH binti ZAILANI and my metric number is DE190084. Today I will present for the coefficient of Pearson correlation and the meaning. So this is our table of the Pearson correlation coefficient. So as we know, the Greek letter for rho for the population parameter and R for a sample statistic denote Pearson correlation coefficient. The correlation coefficient is a single number that expresses the degree and direction of a linear relationship between two continuous variables. The range of possible value is -1 to +1. It may be quantified by its intensity, which is the biggest the absolute value of the correlation coefficient, the stronger the association, and by its direction, with the sign of the correlation coefficient indicating the relationship direction. The Pearson correlation coefficient is equal to 0.140769883, which is a moderately positive association number according to the table. Now, I will show how to find the value for the Pearson correlation coefficient. It to write equals Pearson, open bracket, and now we will select the data X from 1 to 100. Next, we type comma, and then we will select the second data Y. Then we will type close bracket, and then we just click enter. So now here is the value for the coefficient. It's 0.140769883. Next, we will find the value of n. We just type equal count, and we will select the data, close bracket, and then we click enter. So for our value of n is 100. Next, to find the t statistic, we need to click equals, open bracket, we will choose the coefficient value, and then times with, open bracket, square root, open bracket, we will choose the value of n, minus with 2, close bracket, 1, 2, 3, and then for all the value, we will divide with, open bracket, square root, open bracket, 1 minus with the coefficient value, which is a power of 2. And then we need to close the bracket, and then we just need to click enter. So here is the value for the t statistic, which is 1.407566807. So to find the df, need to click equals, and we will choose the number of n minus with 2. So here is our df value. So lastly, to find the p-value, which is Pearson correlation coefficient value, use t statistic, which is with type equals t distribution, open bracket, we will choose the value of t statistic, comma with df, and we choose 2 till, close bracket, and then we just click enter. So now here is the final value, which is 0.16242386. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is MUSTAQIM, and I will do the hypothesis test for hash node beta node not equal to 0 and hash node beta 1 not equal to 1 by taking 5% level of significance. So to do the hypothesis, we use the data analysis and we choose Z test for 2 sample for mean, because this data the n value is more than 30 and there is an unknown sigma. So for the range, we use x value, and for the variable 2, we use y value. So the variance, we pick this value 1.008167192 and 1.0367842113. So tick the label, and alpha we have 5%, so the value for alpha is 0.05, and then so we have here Z test for 2 sample mean. Okay. After that, for the hypothesis test for the slope beta 1, so hash node beta 1 equal to 1 is null, and hash 1 beta 1 not equal to 1 is a claim. Or based on this hypothesis, we can prove that this is 2-tailed test, because the claim is not equal, and we have here ZC equal to Z alpha over 2, so we have Z 0.025. By using the table, we able to get the ZC plus minus 1.96. So the statistic test, Z test equal to 0.4632. So decision to not reject hash node when Z test less than ZC or not in rejection region, since Z test less than ZC, and do not reject hash node. We can conclude that beta 1 slope is not equal to 1 because there is enough to support the claim. And for the hypothesis test for beta node, hash node beta node equal to 0 is a null, and h1 beta not equal to 0 is a claim. So decision rule, do not reject hash node when z test less than z 0.05. so this also to tail, so zc equal to alpha over 2, so we can get z 0.025. by using the table we can have zc plus minus 1.96. so the test statistic z test equal to 0.4632, and the decision rule, do not reject hash node when z test less than zc or in the rejection region. Since z test less than zc, we do not reject the hash node, so we can conclude that a beta node interception is not equal to 0. That's all from me. Thank you.
Assalamualaikum Doktor. Jadi I will present the slide of I, which is compute the coefficient of the determination and intercept the meaning, which is in restriction model. The coefficient of determination, which is R2, is a statistical metric that determines how much variance in the independent variable is explained by the independent variable. In a nutshell, the coefficient of determination indicates how well the data match the model. For the last but not least, by referring the linear relationship straight in the graph y equal to 0.1428x minus 0.0818, we can see that the R2 is 0.0198. So by multiple the value by 100%, we will get 1.98%. That shows that the coefficient of the determination of 1.98% of the data fit the regression model. A higher coefficient indicates a better fit for the model. So I will explain this. I mean, which is we go to the cell. So this is our graph, which is the model that I say, the data of the model that I say. So this is the y equal to 0.128x minus 0.81x18. So which is this line, and then the r square is 0.0198. That's all from me. Thank you.